Explain the worksheet that you did here, the probability number 2 worksheet, and give you an opportunity to kind of check your answers. But on the first one, they talked about of all the people who fly in United Airlines, there's a 0.33 probability that they have a frequent flyer account. An agent helping people confirm reservations and check baggage over the busy Thanksgiving Day weekend is also recording whether each passenger has a frequent flyer account. All right, part A says, explain what the probability of 0.33 means in this setting. Okay, so basically anytime we have a probability, remember it means for a large number of, in this case, flyers, roughly 33% have a frequent flyer account. Okay, so the big thing here is this has to be for a large number of flyers. So part B wants to know, okay, well, does this probability say that if 100 customers are chosen at random, exactly 33 of them will have a frequent flyer account? Well, no. And the reason is probability is not exact. So the 0.33 does not mean we have exactly 33 out of 100, but it means in the long run, we're going to be close to 0.33 or close to 33%. So it doesn't guarantee results. All right, part C. The agent observes 9 consecutive passengers without a frequent flyer account. She presumes the next passenger is very likely to have a frequent flyer account. We want to explain the flaw in that argument. Well, basically, when we think about this, the previous results don't predict future results. So probability, again, it's over a long range that we expect something to happen a certain amount of times, but it's no guarantee. There's no prediction for future results. So those 3 problems were just kind of to get you to get a little bit of an understanding of what probability means. The second one was actually listing out a sample space. So they talked about spinning a spinner with 4 equal sections, and they gave you the 4 colors. And you're going to spin it 2 times. So we wanted to list out all the possible outcomes for spinning it 2 times. Maybe you organize this one with a tree diagram, which would be a good way of doing it. For instance, maybe the first spin was red, which means then you have blue, green, and yellow possible for this. Or actually, I'm sorry, for the second one, you still have red as a possibility. So I could have gotten red and then red again, red then blue, red then green, red then yellow. That was a possibility. Or if you got blue the first time, you still have the same 4 colors for the second. Or green, and finally yellow. So that would be our sample space. That would be all the possible outcomes that we have. Well, they said if we're going to define event A as spinning blue at least once, we want to find the probability of A. So we're going to go through of all these options, how many include spinning blue at least 1 time. If we go to the first situation, we had 1 time where we spun red and then we spun blue. So there's 1. The second one, we got blue on the first spin. So already we've taken care of spinning it at least once. So there were 4 options there. If I spun green first, that only leaves me one option. And if I did yellow first, that only leaves me one option. So out of all these different possibilities, there were 7 times that we had spun blue at least once. Out of, if we think about all the possibilities, we had 4 in each grouping, so that was a total of 16. So the probability of spinning blue at least once was 7 out of 16. All right, the next problem, we had this situation. They were looking at the coupons, and they were mixed up, and they're looking at what the probabilities were for winning certain prizes. And we wanted to know what's the probability that a customer didn't win an entree. Well, if we look at the probability that they did win an entree, it was 0.05. So this is one of those complement problems. So I'm going to take 1 minus that 0.05, and so we have a 0.95 or 95% chance that they did not win an entree. All right, number 4 talks about making a Venn diagram for the situation where different students like chocolate ice cream, strawberry ice cream, and some of them like both. Let's set up our Venn diagram, and then we'll use that to help us answer our questions. So like always, we're going to start with the intersection. So they said 30% like both. If I made this chocolate and this strawberry, the chocolate circle should have 70 total. So we'll put 40 in this little section. We already had 30. Strawberry was 40%, so that leaves me with 10 here. Still have to draw the rectangle around it. Still have to think about what's missing. So right now I have 70, 80% total, so that leaves me 20% that didn't like either one. All right, so let's answer the questions using our Venn diagram. Part B wants to know what's the probability that we select a student and they like chocolate or they like strawberry. So this is one of those where I'm going to first of all figure out the ones that like chocolate and strawberry. And I'm going to take away the ones that like both. So 70 plus 40 is 110, minus 30 means 80%. And I can double check that because it should be the totals I got inside the circles. Part C talks about liking chocolate ice cream and not liking strawberry. So what I would probably do is I would look at my Venn diagram. And in the Venn diagram, I look at, first of all, the ones that liked chocolate ice cream. Well, we have a total of 70% there. But I'm going to take out the ones that did not like strawberry. Well, that was 30% of those. So the part that liked chocolate but not strawberry would be 40%. Then the last one, this is one of those conditional statements. What's the probability that they like ice cream, chocolate ice cream, knowing that they like strawberry? So we're going to start out by looking at, well, what's the probability they like both, divided by the probability of the given factor, they like strawberry. Well, the percent that liked both was 30. The percent that liked strawberry was 40. So we're looking at a probability of 0.75. Then the last problem, it dealt with the two-way table. This one looked at the students, whether they ate the large, small, or student center, large cafeteria, small cafeteria, or student center. And they broke it down by class. So the first thing they want to know, what's the probability of choosing a junior? If we look at the junior row, there were 635 students out of a total of 2,640 students. If you wanted to divide that out, that would be 0.24. Hopefully that one wasn't too bad. Part B, they want the probability of choosing a senior, and they like the large cafeteria. So I'm looking at the overlap between seniors and large cafeteria, and that's 350 out of everyone, 2,640. And when I do that, I get 113. The next one, they talked about having the probability of choosing a sophomore or someone who ate the student center. So an or situation is we're going to look at the sophomore total, that's 650, plus the students that ate in the student center, that was 595, minus the sophomores who ate in the student center, so minus 125. And all that's, again, out of that 2640. And so if we divide that, we find out that was 142. And lastly, we want to know what's the probability that we chose a freshman given that they were in the small cafeteria. So I'm only going to deal with this data right here. Well, in that data, 435 of them were freshmen out of 860 students. And so if I divide that, I get 0.520. So this worksheet, actually, whenever we were in class, I was planning on giving this as a quiz. But since we were not in class, I decided to try it as a practice. But these are kind of some of the main ideas from the first 4 sections from chapter 4.